Hello guys, this is the MEPtutor, and in today's video I'll be solving these three problems. To solve this, we are going to use logarithmic differentiation, which is a strategy to differentiate in an easier way. Okay, so let's do it. Okay, this is the first function we are given, and to solve this, we're going to apply natural logarithm on both sides of the function. Natural logarithm of y is equal to natural logarithm of x to the power of x. Here we use properties of logarithms, and this exponent here we convert it into a product outside of the argument of the logarithm. So we have that the natural logarithm of y will be equal to x times the natural logarithm of x. So here we can use the product rule. So we have that the derivative of this natural logarithm of y is y prime divided by y. I think this is the best conventional notation, the Leibniz notation. Okay, this is equal to the derivative of x, which is 1, times logarithm of x plus x times the derivative of this, which is x prime, in this case is 1, divided by the argument, which is x. So x divided by x times 1 gives us an overall 1. Finally, we multiply this y on the other side. Okay, and we have that y prime is equal to y times the natural logarithm of x plus 1. But we know the value of 1 of y, okay, because it's given since the beginning. So we know that y prime is equal to x to the power of x times the natural logarithm of x plus 1. This is the whole problem. Now let's solve this one. Let's derivate this. And we applied, again, natural logarithms on both sides. We have natural logarithm of y is equal to natural logarithm of the other side, 1 minus 3x to the power of cosine of x. It doesn't matter if it's a constant or a function. In this case, cosine is a function. We use the properties of the logarithms and we move this outside of the logarithm as a factor. So the natural logarithm of y is equal to cosine of x times the natural logarithm of 1 minus 3x. Now we just have to differentiate this on both sides. We have that y prime divided by y is equal to, we use the product rule here, we have minus sine of x minus sine of x times this without being differentiated is natural logarithm of 1 minus 3x, okay, plus the other side, this one without being differentiated, cosine of x times the derivative of this, which is, let's multiply, minus 3 divided by the argument 1 minus 3x. So what we have to do next is to put this y multiplying here, and we replace this y with the original value of y. And we operate this algebraically a little bit. So y prime will be equal to this y, 1 minus 3x cosine of x times the other side minus sine of x as a natural logarithm of 1 minus 3x minus 3 times cosine of x divided by 1 minus 3x. And this is the whole problem. Now, to solve this problem, we could use the quotient rule, but it would be a little bit longer. So let's use logarithmic differentiation. Again, we have the natural logarithm of y is equal to the natural logarithm of x to the power of 5 divided by 1 minus 10x, okay, times the square root of x squared plus 2. Yeah. Here we use the properties of logarithms, and we get that natural logarithm of y will be equal to natural logarithm of x to the power of 5 minus natural logarithm of 1 minus 10x minus natural logarithm of the square root of x squared plus 2. Okay, and that's it. Now we differentiate everything. We get y prime divided by y is equal to 5 times x to the power of 4 divided by x to the power of 5 minus, we get minus 10 divided by 1 minus 10x. And we have minus 1/2 times 2x divided by the square root of x squared plus 2 times x squared plus 2 all raised to the power of minus 1/2, which is square root in the denominator basically. So let's put it here. Square root of x squared plus 2. Yep, just like that. Now we operate this algebraically. We have that y prime is equal to y times 5 times x to the minus 1 plus 10 divided by 1 minus 10x minus x divided by x squared plus 2. Now finally, we substitute the value of y from the original problem. Y prime is equal to x to the power of 5 divided by 1 minus 10x times the square root of x squared plus 2 times the other side, 5 divided by x plus 10 divided by 1 minus 10x minus x divided by x squared plus 2. This is the whole problem.